All right, guys, and wrapping up the end of section 5.1 in our notes, the last thing we're going to work on here is graphing polynomial functions, but doing a really simplistic job of it right now. We're going to learn some more sophisticated and fancy methods for doing it later on in chapter 5, but for right now, we're doing something really basic. We're going to use our calculators here just to make a table of values right here and talk about which values are important and how to use those within our graph. So here's our function here, guys. F of x is equal to, we have a 1, 2, 3, 4-term polynomial, and the highest power that we see here is 3, so this is what we would call a cubic polynomial. Now, knowing what we know in terms of end behavior, which we just got done talking about, this is the only term that matters. And when you put in a positive number, you cube that positive number to get a positive result, times positive 2 is positive as well. So I believe this graph is going to go up on the right. If you were to put a negative number in here, a negative number cubed is negative, times 2 is negative still. So when we move left, we're going to end up, should have probably put that down here, with a value that goes, function that goes down on the left. So down on the left and up on the right is what I'm expecting. Let's see if we can get that to pan out. I'm going to make a table of values here, guys, with x and y, or you could have done x and f of x. That would have been fine too. And in terms of what values we have to put in here, this is a little bit more loosely defined than what we did back at the beginning of chapter 4. So you guys are going to grab your TI-84s and you're going to hit your y equals button and you're going to type this function right here into your Y1 screen. Now, unfortunately, guys, I'm making this video on my iPad and there used to be an iPad app for the TI-84 and they got rid of it. So instead, I'm using something much fancier and hopefully you guys will figure this out. So you'll notice I've taken the time, I've gone ahead and defined this function right here. So for you guys, hit your y equals button in your upper left-hand corner, type in this function here, and then hit enter when you get done. The next thing you guys are going to do after that is you're going to hit second and then the F5 key in the upper right-hand corner, and that's going to take you to a table. And in that table, you should have your first two columns pretty well filled out already. Now, this calculator that I'm using doesn't work exactly that same way, but I got it set up to do something pretty close to that. So hopefully you're recognizing these values that I have in my table. Now, what I want you guys to notice is that some of these values, like negative 1,386, are ridiculously large, or in this case, ridiculously small, and we're not going to be asking you to graph that. But what I want you to look for is within that second column, when do you start to get some y values that are a little bit more reasonable, a little bit closer to 0, maybe single digits, and maybe more importantly, where do you see the y values start to change behavior? What do I mean by that? If you look at my table right here, my y values start off negative. And then what? Negative, 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 negative. This is kind of boring. Negative, negative. And then all of a sudden, it goes to 0. And then it goes positive, back to 0, back to negative, positive, 0, and then a bunch of positives again. So to me, the interesting stuff kind of seems to happen in this range of values right over here. This is where our y values start to change behavior. Now, careful, even though these were all negative up at the top, from negative 1386 to negative 960, we're actually increasing. Okay, and we keep increasing until we get down to where? A certain spot here. I guess when we go from the 0.6 to 0 there in the y values, where this thing actually starts decreasing. Okay, let me take a look. It looks like I've got 1, 2, 3, 4, 5, 6, 7 ordered pairs that I'm going to put into my table here, guys. Negative 4, negative 30, negative 3, 0. Okay, here we go. Negative 4, negative 30, we had negative 3 and 0, and let's see, I think I had negative 2, negative 1, 0, 1, 2, I think that's as far as I went there. So let's see, negative 3, 0, and I got 6, 0, negative 6, 0. Okay, 6, 0, negative 6, 0. And then I think we jumped up. Was that a positive 30 then at 2? Yes, it was. All right, so, whoop, wrong way. There we go. And we had 30 right here. Now, obviously, these two y values are still really, really big, or at least far from 0, so I'm not going to graph them accurately, but roughly, guys. Negative 4, negative 30, I'd go 4 units to the left, and negative negative 30 would be way the heck down here somewhere. But the next 5 points, I think I can graph with some accuracy. Negative 3, 0 would be right here. Negative 2, positive 6 would be up here. Negative 1, 0 would be right there. Got it. We've got 0, negative 6 right down here, and then 1, 0, and then 2, 30. Well, again, here's 2. 30 would be way the heck up here, positive somewhere. Now, in Chapter 4, we would try to come up with a series of 5 points, and usually they would follow a pattern that looked something like this. And I would ask you guys at that point, do you now know what this graph looks like? And you would say, oh yeah, definitely, that makes a parabola, because that's the shape of a quadratic function. Or even back in Chapter 2, we would graph 3 points, and they would maybe look something like this. And you'd say, oh, that's a linear function right there. And that's kind of how we started graphing lines and parabolas. Well, now we're learning a totally new shape that you guys have never seen before. But if you take a look at this series of 1, 2, 3, 4, 5, 6, 7 dots, and you think about the end behavior that we talked about a minute ago, we know that this graph should go down on the left and up on the right. I kind of think that's what these 7 dots are showing you. I'm going to start actually from this point right here and basically draw something that's curving down, looking something like that. But then what does it do? It seems to bounce back down and hit this point here, but then curve back up at that point, and then hit some of these points then on the way up towards infinity. Now, guys, that is not a perfect representation of what this graph looks like, but it's actually pretty darn good. It's pretty accurate, and it does what a third-degree function can do. Its end behavior, it goes up on the right, up towards infinity, and it goes down on the left towards negative infinity, and it takes this big turn in the middle here. The function went up and then came back down and then went up again, and that is a pretty typical feature there of what a positive leading coefficient on a cubic polynomial can do. So this is something we're going to get more familiar with here by the end of the chapter, you guys. But for now, just making a table of values, that's how we were able to come up with a pretty rough sketch of what this thing looked like. Okay, let's move on to a second example, and this one's a little bit different now. This one is a 4th degree, a quartic polynomial with a negative leading coefficient. So if we were to think about end behavior, guys, as x approaches infinity, y, or in this case g of x, would approach. Well, all we need to worry about is this term right here. And let's think about it, guys. When x is positive, we take a positive number to the 4th power. It stays positive, but then we take the opposite of that result. It's negative, which means g of x is approaching negative infinity. This thing is going down on the right. What else? As x approaches negative infinity, so now as we're moving to the left without bound, what happens to g of x? When you take a negative number to the 4th power, negative times negative times negative times negative, that ends up being positive, but once again, you take the opposite of that result to get a negative once more. So this one tells me as we move left, we're heading down as well. So this graph is going to go down on both the left and the right. Let's keep that in mind then. So let's make a table of values again here, x and y, and let's see what we've got. And unfortunately, guys, I did not get this one typed in, so you might have to bear with me here for just a second. What I'm going to do then, guys, is, let's see if I remember how to do this on this calculator. Yeah, I'm just going to redefine my f of 1. For you guys, you go ahead. Why is nothing? There we go. You guys go ahead now, and you're going to go again to your y equals button in the upper left-hand corner. You're going to clear out whatever function you had there before, and now you're going to type this new one in here. So I forgot to name this. Okay, so f1 of x, here we go, is equal to, all right, we had a negative, that was an x to the 4th power. Got it. And then a minus 5x to the 3rd, okay, and a minus 2x squared, and then followed by a plus 8x. Oh, I forgot to hit an arrow to get out of that, darn it. 5x to the 3rd power, there we go. Try it again. Minus 2x squared and a plus 8x. Okay, that is what this function should look like. So let me hit enter now. And again, for you guys, once you get it in there, you're going to hit your second button, top left corner there, and then F5 in the top right, and you're going to go back to your table now, and let's see. Hopefully, if you hit your up or down arrows a little bit again, you're going to be looking at the same values that I'm seeing right here. Now, not only do I start off with some ridiculously big, or in this case, small values right here, take a look at what's happening. These Y values from here to here are increasing. Negative 3150 is actually greater than negative 5280. And it keeps going, guys. Increasing, 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 until we get to this spot right here where our Y value now starts to decrease. Then it keeps decreasing. Then it turns around and increases again. Something weird happens here. I did this on purpose. I wanted you guys to see it. We got the same Y value twice in a row. We'll talk about that in a minute. And then it starts decreasing, 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 and it keeps doing that. So as far as what's interesting here, I'm not going to plot negative 90, guys, but I do think that maybe going about this far on my table would be kind of good for us right here. Okay, so let me jot some of this down right here. In fact, I can't just take a shot of that, can I? What if I... Sorry, everybody. Trying to learn something new right here, and I don't know if that's going to work or not. Nope, it didn't. All right, so negative 5, you know what, I'm going to jot this down right here so I don't have to bounce back and forth here. So we had negative 5, negative 90, negative 4, okay, 0, 12, 0, negative 6, 0, 0, negative 48 happened at 2. Okay, all right, so... let me fill in this table here, guys. We went from negative 5, I believe, all the way up to 2. Negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. And let's see, we had negative 90. We had a 0. 12, another 0. Negative 6 at negative 1. 2 more zeros. There's a reason I'm hitting that so hard. You'll see that later on. And negative 48. All right, let's plot and see what we got. Negative 5, negative 90. I'm not going to graph that accurately, but negative 5 is right here. Negative 90 would be way the heck down here somewhere. Close enough. Now I think we can be more accurate, though. Negative 4, 0 gives us this point right here. Then we've got the point negative 3, 12. Well, here's negative 3. 12 would roughly be up there somewhere. It doesn't have to be perfect. Negative 2, 0 gives us that point right there. Negative 1, negative 6, there's a point. 0, 0, this one actually hits the origin, got it? And then we've got the point 1, 0, and then 2, negative 48, which again is way the heck down here somewhere, and there you go. So let me kind of ignore those little lines that I put there, which I probably shouldn't have, and they're just kind of getting in the way of things here. So I can erase that and that. And let's take a look at what we have here, guys. 1, 2, 3, 4, 5, 6, 7, 8 points. And when I try to connect all these dots and pay attention to my end behavior, which tells me this function goes down on the left and down on the right, I'm going to kind of start from this high point right here and hit something that goes down here very steeply, looking like that. It's then going to go down on the right as well, but then hit this point and turn back around. And then something weird happens right there, guys. It would not be natural for this function just to move straight across like that. What this function actually does is it moves ever so slightly above the x-axis and then comes back down to it. That's what has to happen when you have 2 zeros in a row in your y-coordinate and these x-coordinates are only apart by 1. And then it's just going to keep hitting down this way through that point and go down towards infinity on the right. Not every fourth degree function looks exactly like that, but that's what this one does. So those last two examples are meant to give you guys just some sense of how we can determine the shape of some of these higher order polynomials. We did a cubic polynomial here in 3a and then a quartic polynomial here in 3b. And later on in the next chapter, the next section, we're going to start talking about these guys right here, which are called turning points, where the function changes behavior from increasing to decreasing, or vice versa, from decreasing up to increasing. But we'll get to that a little bit later in 5.2. As it is, that's probably enough right now for 5.1. Pretty long section, but hopefully that's giving us a handle on how some of this works at the beginning of Chapter 5. Good luck, everybody.